Good afternoon, I'm Mr. H. Thank you for joining me. We're looking here at a very basic function which has asymptotes, and that function is f of x is equal to 1 over x. It's a very basic rational function which looks something like this. And you know, you're familiar with this graph, 1 over x. It never crosses the 0 mark in terms of your vertical and in terms of your horizontal, but it has two types of asymptotes. You have three types of asymptotes in general. You can have a vertical asymptote, you can have a horizontal asymptote, and then you can also have oblique asymptotes. Asymptotes are basically imaginary lines where either your function will graze along that line, or a vertical asymptote such as that where the domain, the x-axis value, is not defined with regards to that value of your vertical asymptote, or a horizontal asymptote where your function will graze along it because in terms of the output your function reaches at that level but doesn't really cross it. So when we're looking here at this very first question, demonstrate any horizontal asymptotes, you're looking at a function which is 1 over x. You have to demonstrate a certain value, n value and m value. The n value represents your highest degree of exponent in the numerator, m represents the highest degree of exponent in your denominator. When you look at this function, you can rewrite it as x to the 0 divided by x to the 1. Anything to the power of 0 is equal to 1. Now when you're looking at this, your n value happens to be 0. When you're looking at this, your m value represents a 1. There are three instances. When n is equal to m, there's a specific type of asymptote you can find. We can learn that in another video. When n is less than m, there's a specific type or a standard type of asymptote which you will always go to. And then when n is larger than m, there is no horizontal asymptote, and I'll just cross that out. Your real situations are only these. In this specific example, we're looking at n is less than m because 0 is less than 1. Whenever n is less than m, you have a standard horizontal asymptote of y equals 0, which is why this function has a horizontal asymptote, and that right there is your x-axis, y equals 0. So you have to remember that at any instance n is less than m, you're doing a horizontal asymptote, y equals 0. Your x-axis is that horizontal asymptote. And again, you have to remember what n and m are. N is your highest order degree of exponent in the numerator. M is the highest order degree of exponent in the denominator. Keep that in mind. Now, in the second question, we're looking here at the concept of vertical asymptotes. What's a vertical asymptote and how you determine it? Well, you determine the vertical asymptote by calculating the 0 of your function. You always look at your denominator polynomial and you equal it to 0. Here your denominator polynomial is just an x, you equal it to 0, and that right there is your vertical asymptote. Here your vertical asymptote would be your x equals 0, which is your y-axis, which is why the hyperbolic function, or this basic rational function, has a y-axis vertical asymptote. And there it is, your vertical asymptote. And it also happened to have the x-axis as your horizontal asymptote. Your y equals 0 and your x equals 0 are your two asymptotes for this specific function, which is a very basic rational function. Keep in mind, your vertical asymptotes are represented by the zeros of the function, and you look at the denominator for that. The horizontal asymptotes, you look at the n and the m value. Just as a very quick question over here, look right here, f of x is equal to 2x over x squared minus 1. If I were to tell you to find the horizontal asymptote, now you're looking at the n and the m values. Here the n is a highest order degree of 1. Here the m is a 2. N is less than m. Therefore, you're going to say y equals 0 is your horizontal asymptote, which right here is your x-axis. Now for the vertical asymptote, you're going to focus only on the denominator and you're going to find the zeros. Calculate the zeros of your denominator. Zeros are those values of x which will zero out your denominator. You'll do x squared minus 1 equals 0. X squared is equal to 1 and x is equal to plus and minus 1. And those will be your vertical asymptotes. X is equal to 1 and x equals minus 1 will be your two vertical asymptotes. The other way you could have done this is you factor x squared minus 1 into x minus 1 and x plus 1, and you make them into 0, and you individually solve for x. You'll have a plus and minus 1, exactly as we've shown you. A useful benefit of doing the asymptote determinations is you can use them to help draw a graph. If you were to graph this 2x divided by x squared minus 1, you know horizontal asymptote is your x-axis. You also know vertical asymptotes, x equals 1, x equals minus 1. If you were to graph this, you know if you put value of 0, you zero out the numerator, but you can't zero out, you'll have a 0 minus 1. You can't zero out the denominator, so you know the function will go to the origin. You would very likely have a graph which would look something like this, and something like this, and then it would go like that. It would be split among three parts by your asymptotes, your vertical asymptotes especially. And think about it, if you put a negative value over here in terms of x, you're getting a negative over here and you're getting a negative here, you have a positive output. If you put like a positive half over here I was saying put a minus half, here put a positive half, you'll have a negative value. If you put like a x-axis value of a minus 1 over 2, you'll have a positive output. If you put x is equal to 1 over 2, you'll have a negative output. In between this minus 1 and positive 1, vertical asymptotes. You can only put these fractional values in between, and they would be good test values to use. Anyhow, your graph would look something like that. But the main point over here is for the vertical asymptote, always look for the zeros of your function. For the horizontal asymptotes, you look at the n and the m. The exponent degrees in the numerator and denominator, and you compare the two and see how they are. In this video, we only looked at this specific aspect where n was less than m, and it always leads to this type of horizontal asymptote, y equals 0. But that'll be it for this video. Thank you for watching. Have a nice day.